The vast distances that exist in the vast reaches of space frequently surpass our capacity for imagining. Although experts recently discovered one of the most distant and thus oldest galaxies in existence, there are still many unanswered questions about why this is the case. Today's video will tell you what we currently know about this remote collection of stars. There are times when some cosmic structures are so far away from us that even light takes billions of years before it reaches our terrestrial field of view. If you're enthusiastic about new discoveries and unique cosmic spectacles, don't forget to click the bell and subscribe to Simply Space for frequent updates on these fascinating subjects. Giving us a thumbs up encourages us and demonstrates that we can maintain your interest in the video's substance. Foreign music. As far as we know, the universe was created around 13 billion years ago. Although the Big Bang's official name sounds incredibly violent, it actually describes the process by which matter, space, and time emerged from a previous, the singular. In astronomy, the term singularity refers to locations where the gravitational pull is so great that space-time diverges or becomes infinite. However, how can we truly know how the universe came into being? The answer to this topic. Turning the cosmic wheel of time backwards reveals that the universe is by no means a rigid, unchanging structure. Quite the contrary is true, as the expansion of the cosmos causes our galactic home to expand continuously. However, this expansion does not occur in an existing space. Rather, the space itself is constantly growing. We will eventually get at a point when the density of matter and the density of energy become limitless if we now reverse the evolution of the expanding universe, returning us to the Big Bang's beginning. Already some 100 million years after the birth of the universe, the first star saw the light of day. What for us still represents an unimaginably long period of time is in the overall context of the universe's development. No more than a fleeting blink of an eye how the cosmos succeeded at that time in transforming itself from an extremely simple initial state into a construct of the exuberant variety is a subject of research until today you might say our domestic solar system is a kind of galactic late starter our home system developed only approximately 6 billion years ago. Things were quite different in the case of the galaxy HD1. The light of this remote entity needed no less than 13.5 billion years before it reached us. Expressed in other words, this means that the experts see the galaxy today still in the condition in which it presented itself just once, 330 million years after the Big Bang. Thus, the recently discovered HD1 is no less than one of the oldest known galaxies at all. What initially appeared as a strange red glow on the images turned out to be an absolute sensational find after a more detailed analysis. However, a central mystery about HD1 remains. Why can we see the light it emits at all questions and explanation attempts? Since it is currently completely unknown why the galaxy shines bright enough for us to detect, the urgent conclusion is that high-energy processes occurred in HD1 billions of years ago, causing the galaxy to shine surprisingly brightly in ultraviolet light. However, astronomers discuss two potential explanations for this phenomenon. Given that the celestial bodies of that era were much hotter, more massive, and more luminous than today's stars, it is possible that many stars of the first cosmic generation were born in HD1. Against this backdrop, the unexpectedly intense brightness in the ultraviolet spectrum could be explained. According to current research, it is believed that practically every galaxy center is adorned with one of these enormous gravity monsters, and the Milky Way is no exception. The second explanation is based on the influence of a supermassive black hole, Sagittarius. If the second theory is confirmed as the cause of the surprising brightness, experts will be faced with another mystery. How could such a massive gravity monster come into existence just 30 million years after the Big Bang? In this regard, scientists say it would be extremely difficult to decipher the background of the black hole. A star has a mass of about 3.7 million solar masses, which makes it much sparser than the presumed black hole at the heart of HD1, whose mass would exceed that of the Sun by a factor of 100 million. What is certain, though, is that the discovery of this ancient galaxy was a monumental undertaking. In total, the Harvard-Smithsonian Center for Astrophysics researchers spent more than 1,200 working hours analyzing over 700,000 structures in isolated regions of the cosmos before HD1 finally showed itself by its striking reddish coloration. This phenomenon is known in astronomy as redshift, and it results from the universe's constant expansion, which causes the light emitted by the galaxy to shift more and more toward the reddish end of the spectrum to do so. Following its discovery, Glass C13 was recognized as the oldest galaxy ever discovered. Only a few months later, HD1 had to give up this title to the Glass C13 collection of stars, which is another 30 million years older than the previous record holder. However, the analysis of this fascinating discovery offers us a glimpse into the past and a preview of what lies ahead for Glass. In fact, C13 has been detected on images captured by the James Webb Space Telescope. As we know, one of the primary functions of this intricate piece of technology is to search for the first galaxies and luminous objects that formed during the so-called Dark Ages and after the Big Bang. In particular, Webb was built for infrared astronomy and is up to 100 times more sensitive to electromagnetic waves than its Hubble scientific predecessor. To understand why Webb is rightfully referred to as the most powerful telescope ever, it is worth considering the following example. If the $10 billion piece of equipment were on Earth, it could detect the heat emitted by a tiny bumblebee on the Moon. At the same time, Webb's NIRCam operates in the near-infrared range, making it a great tool for detecting distant red-shifted light sources. In the meantime, we know that the experts' dedication was worthwhile because they were able to identify two early collections of stars. The first, which was given the scientific name Glass Z11, formed approximately 400 million years after the universe's creation, while the stars of Glass C13 saw the cosmic light of day another 100 million years earlier. Of particular interest, the researchers were able to uncover some basic features of the two galaxies by studying the light spectrum. Accordingly, the mass of the star collections is given with 1 billion solar masses each. If you have recently visited our channel, you probably remember that we introduced you to the first spectacular Webb images. For clarification, Glass C13 is 700 light-years larger than Glass C11, which is 1,600 light-years. The two primordial galaxies are pronounced dwarfs, with the size of our home galaxy, for instance, estimated at 170,000 light-years. Despite their relatively compact size, the early galaxies appear remarkably active. The data collected thus far suggests that they emitted enormous amounts of UV radiation, which suggests that extremely large numbers of stars were once formed in the galaxies. However, the astronomical length measure of the light year corresponds to the distance that light covers in the vacuum in a year, 5.9 trillion miles. The younger representative Glass C11 is much less disordered than experts had assumed. For such early galaxies, it seems that Glass C11 already had the typical disk shape that we find in many younger galaxies. In view of the euphoria that the discovery caused in the ranks of experts, we should not forget, however, that still some uncertainties in the data sets exist, according to the experts. This is because we are dealing with the first deep fields made by a completely new space telescope. However, since the captured light signatures turned out to be very clear, in both cases, the experts are sure that their basic explanations are consistent with reality. Now, we want your opinion. What do you think about the ancient galaxies recently added to the star charts? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. We appreciate your attention. Be careful, and we'll talk to you soon.